Hello and welcome to Kids Code Camp 2020. Bit of a different scenario this year. First time we're going to be doing everything completely virtually. So hopefully this goes well. If not, at least everything's recorded so you can always go back and review it and hopefully get some more information later. But this is how we're going to be presenting all of our different projects. You can see I am using a website in this case. Oh, this is the JavaScript piece, by the way. I'm using a website. It is codesandbox.io. This is where I'm going to host all of the different files. You can see we have some past years information here from 2019, 2018. This is where we generally work for the JavaScript pieces. It's a good website. It's got all the different things you'll need. It's got editors. It's got project structure. The reason we do it this way is so that you don't have to install anything on your actual computer if you don't want to. You can just go to this website, create a new project, and off you go. Everything else is handled for you. If, however, you do want to have everything on your local machine, you're going to need to download two things. One is Node.js, and go ahead and just use that LTS version. It may not be these same numbers. They may have updated by the time you download it. That's okay. Just pick the one that says LTS, and you'll be fine. You also need a code editor, and that's going to be Visual Studio Code. Okay, there are others out there. Code is the one that I prefer, the one I'm most familiar with. Seems to have the best system. I've used others, and Code is always the one I come back to, so it's the one I recommend. If you're not running Windows, that's okay. You can click this drop down and get to other versions, or if you want the 64-bit user install, you can do that as well. But download this, get it installed, download Node.js, the LTS version, get it installed, get everything set up, and you should be good to go. If you are using the website, you'll notice here that I'm logged in. You can see my little Homer Simpson avatar picture. Okay, everything is going to be loaded up. You may not see the same kind of stuff if you're not logged in. If you choose to log in, that's okay, but you shouldn't need to. All we really want to do is just create this sandbox here, and that should get us where we want to go. I'm going to go ahead and do that. It's going to bring up all my different options. I've got a bunch of different templates down here I can pick from, some using React, some using Vue, some using Angular. There are lots of these different frameworks that we can pick from. We're not going to need any of that, but if you ever do want to create your own full website, go ahead and pick these, and they will make your lives a lot easier because they will save you a lot of work in making things show up. We, however, are just going to pick the vanilla JavaScript, and that's going to go ahead and create a new project for us. And it's got a couple of different things here. You can see over here on the right, we have, it's calling it browser. This is just a baked in little sort of demo area. And then we have our editors over here on the left. We've got our file structure. Everything that you would normally see on a desktop we have, so we can build everything just like we normally would. Now, if you're not using the browser and you want to use this with, you know, your whatever folder, whatever Visual Studio Code and Node.js you've got installed, go ahead and do that. Create yourself a new folder somewhere where you want to create this project, name it whatever you want, and then just open that folder in Visual Studio Code. Again, I'm not going to go through the steps for that because I'm going to recommend that you use the website, but if you want to use Visual Studio Code, go ahead and create a new folder, open that up. Once you've got that, you can use npm, which can be installed with Node, to create this package.json file. Now, the rest of us won't have to really do anything in here. If you want to, you can change you can change the name and the description, leave everything else alone. Name and description are okay to change. The name has to be all lowercase though. I'm going to go ahead and just leave them. But that's what that's going to be. And this is going to create all the information about what sort of dependencies we need, which we're not going to need any. We also have this index.html file. Now, HTML is the stuff that defines the structure of your web page. So you've got this head section up here, you've got a body section down here. Again, this is all generated for us with Code.js or the Code Sandbox. We don't have to do too much to get things started, but all this is here. And we'll talk about what the different pieces do later on as we go. One thing we can change real quick, rather than being parcel sandbox, I'm just going to make this a KCC JavaScript 2020, just so that shows up in our title. So now that I've saved, you can see it does give us a preview over here, and that's all they've given us so far is just this really basic web page. Inside this src, this source folder, we have two other files. One is index.js and one is styles.css. Styles should give you an idea of what it does. The CSS file defines how things should look. So our HTML gives it structure. It tells it this is going to be a headline. This is going to be just a paragraph. Then we can use the CSS file to style those. So if I tell it that I want this headline to have a blue color, go ahead and save that. You can see it loads it back up and the headline is now blue. And we're going to be doing more of this, but for now, just know that CSS means styling. It's actually cascading style sheets. It's in the name. But styles is where our styles are going to go. Anything that ends in JS is our JavaScript. That's where we're going to be doing all of our coding. So anything that we need to do that's functionality, moving things on the screen or defining how our game is going to run, that's all going to be done in the JavaScript file. And we'll be creating more of these as we go, but right now we just have this index.js file. Don't need to worry about this too much just yet. We'll come back to it. But if you're starting on your desktop, make sure you get a new folder, open it with code, and then create these files here so you have the same structure. Don't worry about the content. They might have it be the exact same stuff because we're going to delete this anyway. But make sure you have these same files to start out because that's where we're going to start from. Okay, so now that we have our basic setup ready to go, now we can start changing things so that we are getting what we need to make things start. So let's start with our HTML file. As I said earlier, the HTML file is what's going to give it the structure of our web page. There are a few things we're going to need, and we want those things to come inside this body section here. First thing we're going to do is go ahead and take this div. We're actually going to leave the div alone, but rather than having an ID of app, we're going to make this have a class of grid. Okay? And then we're going to add some stuff inside this div. So a div is just sort of a container that allows us to put other things inside of it. One of the things we're going to put inside of it is a canvas. And a canvas is a JavaScript, well, it's an HTML way of letting us draw on the page with JavaScript. Of course, we can draw other ways, but canvas is a way of letting us draw things like a game. Okay, I'm going to give this an ID of board because this is where we're going to be putting all of our game information. I'm also going to give this a class of game board. And I'm going to go ahead and close off this canvas. So with HTML, anytime you have an open tag, which you're going to have this little left arrow bracket, and then the name of the tag, you also have to have a closing one. And you do the closing by the same left arrow bracket and then this /, and then the same name. You can see with our div, we have the arrow, the bracket, div, end of the element, stuff inside. And then we have our closing bracket, our closing element, which is the div, with the / in front of it. And that's just the way we tell the HTML, tell the browser, I want these things to be contained by these things, and I want them to be part of this particular piece. It's just the way we lay out the page. And again, our canvas is going to be the thing that tells us, all right, lets us draw on the page. Next, we're going to add another div, and div just stands for division. We're going to give it a class. And then we make sure we close off that div. So we have an open and a close tag. Now I can put stuff inside here, give another div. Okay, we have our open and our close tag. Come back up here in the middle. And then we're going to have an h1 tag. And we want this to say Tetris. And now the h1 tag stands for header. So we want this to be the big important piece of information that tells us what's going on. Okay, next we're going to have the score. I'm going to create a span, and I want that to say that the ID is score. And then our p tag. So our p tag stands for paragraph. Span is just a span. It's just a section we can write stuff in. Okay, I'm going to create a couple more of these. I want score, I want lines, and I want level. Okay, so we have 3 paragraph tags. We have a score, a lines, and a level. And each of those has a span with an ID of the same names. We're going to use these later on to display information about the game. So obviously our score, number of lines, and which level we're on. Okay, so we're going to use this structure to do that later. After that, we're going to have another canvas. If I can spell. Yep. And this time we're going to give it an ID of next. A class of next. And this canvas, again, canvas lets us draw on the web page. We're going to use this to display what the next coming up piece is. So if you've ever played Tetris before, you know that it has the game board, and then it'll show you what the next piece is going to be so you can plan for it. we're going to use this canvas to show what that's going to be. Okay, now inside the right column div, but after that second div, we're going to create another button, I guess a button, and we're going to give it an on-click event handler. Okay, now normally we wouldn't want to do it this way. We want to have something in JavaScript, wire this together, but for the ease of simplicity, or in the interest of simplicity, we're going to go ahead and just do it the old school, simplest way. Okay, and for now, that's really all the more we're going to need as for our structure. So we have a grid up here, we have a canvas, which is going to be our game board. We have this right column, headline, information about the game, section to draw the next piece, and then finally a button to let us start the game by hitting play. Okay, now we can come back over here to our JavaScript file, our index.js file, and we're going to go ahead and delete everything that's in here that the project started us out with. First thing we want to do, we created this canvas over here that's our game board. We need to be able to get that inside our JavaScript so we can use it to draw. So I'm going to call this game canvas. Okay, and we're going to use some JavaScript APIs here. I don't let the fancy terms fool you. Okay, APIs are just ways of getting things to work. So first thing we have is this concept of a document. Okay, this document represents our HTML document because it allows us to get information from the web page. We're going to try to get some element by its ID, and I'm telling it that I want to get the thing with the ID of board. So if we look over here at HTML file, notice that the ID with board is our canvas. Okay, so that means that this element, or this game canvas thing right here, is now going to hold that canvas element. Okay, which brings us to the first piece of programming. So this is called a variable. Okay, now it's a constant, but we're not going to worry about the difference between those two for this particular case. We have a variable which is game canvas, and game canvas is going to let us access that canvas as we work. Okay, now canvases can let us draw, but we need to be able to get to them a specific way. So I'm going to create another variable. I'm going to call it game context. Okay, and I'm going to use that canvas, and I'm going to use another one of its API methods, which is get context. I'm going to pass in 2D. Okay, so canvas can be used to do a lot of different things. You can make three-dimensional games with it. In fact, if you go and look up some games in JavaScript, you'll see that there are a lot of three-dimensional games built in JavaScript. And they're using this concept of a canvas with a context. So with this, we're going to get a 2D context because we don't need to worry about 3D. We only really want a 2D thing. Tetris is a 2D game. So we're not going to worry too much about that. Okay, now I'm going to come in here and I'm going to tell it how big I want the game context to be. I'm going to say game context dot canvas dot width equals, and I'm going to use some more information that we haven't defined yet, but that's okay. We're going to get to it in a minute. I'm going to say calls times block size, and then next I'm going to say game context dot canvas dot height equals calls times rows times block size. And I just realized I spelled width wrong. Okay, so this is going to let us tell the game how big we want things to be. Next, I'm going to tell it to scale. I'm going to say context.scale. And I'm going to use the same block size thing. I'm going to give it to it twice. All right, so let's explain what's going on here. We've got our canvas, which we used our document to get. Then we got this 2D context from the canvas. And now we're telling it that we want to set some information about this canvas. We're telling it we want the width, how wide it's going to be, the height, how tall it's going to be, and then the scale. Okay, so that's going to tell us how big over here we want this to be. We're going to use these other variables to do that. We haven't defined these yet, but that's okay. We will in a minute. we're going to leave this for now. Then we're going to go do some styling. The first thing we need to do, if you look up here inside this head, or anywhere on the page, you'll notice we never actually include the style. Okay, and that's because it's being done right here in our JavaScript. We don't need to include it on our web page. Sometimes you will see it on a web page though, and that's perfectly acceptable. We're just going to do it by using this import statement right here. Okay, now we did this or as soon as the project started up. We're going to go ahead and rid that now. We're going to add some more pieces to our styling. Okay, first thing we're going to want to do is change this font family from our body. Rather than being sans serif, we're going to use a new font, and we're going to say press start 2p, and then cursive. You know what this is going to do is it's going to use a font called press start 2p. Well, the browser doesn't have that built in. It has no idea what that font is going to be. So we're going to add a new piece to tell it how to get that font. So let's come back to our HTML file. And right here inside the head, we're going to tell it how to get that font. We're going to create a new link. Okay, and a link is just going to tell it to download something from another location. We're going to use this href. And href tells it where we're going to get that information. So I'm going to tell it HTTPS. And then we're going to download this from the Google Fonts API. Okay, we're going to tell it the family we want is that press start 2p. Okay, and then we need to tell it that this thing that's linking is a style sheet. We can close off this link. Okay, so now what we've done is we told it that we want to download this font and tell it that that's going to be a style sheet. So the browser will now do that. Now over here, when we tell it that the body should have a press start font, and in fact, I'm even going to say HTML just to make sure everything uses that font, then we're all going to have that same font and it should look the way we want it to. Next, we're going to do a style that's going to tell us how to define that grid. So you come back here to our HTML, you'll notice we have this class equals grid. Okay, well, these classes allow us to apply styles to this div. So I can give it a background, I can give it a border, I can change how things look inside of it. And I can do that all with these class assignments. So as we go, I can define different classes, and that's going to allow me to apply different styles. So I could create a class that changes all the color of the text to green. I could maybe call that text green. Okay, and by applying these two styles, grid and text green, the text green will make the text green, and then grid will do whatever it's going to do, but I can apply multiple styles so that we change how things work. So one of the styles I want to apply is this grid. So to do that, I'm going to put a dot grid, okay, and then I'm going to tell it that I want to display this as a grid. Okay, next I'm going to tell it that I want to template columns, and I want them to be 320 pixels by 200 pixels. Okay, normally we wouldn't be using pixels here, but again, this is just going to be very simplistic, so I'm going to keep it simplistic. That's going to tell it exactly how big and tall we want this grid to be. Okay, next, I'm going to tell it the right column. This time I want it to display flex. Okay, now these display properties, they all do different things. So a grid, if you imagine just a grid like you're used to, right? Like a tic-tac-toe section is a grid, or if you've done any graphing in school, you're going to use grid paper. Okay, it's just a series of vertical lines and horizontal lines. We want to define how big we want those to be. So in this case, we want to have two columns, one that's 320 pixels, one that's 200 pixels. Okay, if you want to make yours wider or smaller, you can. Let's do that later. In this case, I want to display it flex. And flex just gives us the ability to lay things out automatically without having to tell it exactly what we want. So I'm going to tell it that I want the flex direction to be column. That means it's going to lay things out up and down. And then I want to justify content with space between. Okay, that's going to tell it that everything that's inside this right column is going to have space in between it, so it fills up all of the available space. Next, I'm going to do a game board. We'll give it a go ahead and give it a solid 2-pix border. Backward. Okay, and last we're going to do the play button. Now the play button, we want to look at specific things. We're going to give it a background color. And here we're going to use some interesting characters. I'm going to use this pound symbol or hash symbol, whatever you want to call it, number sign. Then I'm going to do some letters and some numbers. Okay, this is known as a hex code. And you can see if I hover my mouse over it, it brings up this little color chooser. That's something that happens in Code Sandbox. I don't know, well, if you have a plugin for Visual Studio Code, it'll do that for you, but if not, it won't. You can see I can come in here and pick any color. This series of characters means that I have picked this color, and it'll even show what that means for me. So that's the color my button is going to be. Okay, next I want to tell it the font size is going to be 16 pixels. And that just tells it how big the letters are going to be. Okay, now I'm going to do a 15-pix border or padding, which will give it an effective border of space. And then just to be sure, I want the cursor to be pointed. Okay, so all these things are going to tell the web page how it should style all these different elements. We have our grid, our game board, there's that right column, and then there's our play button. So each of those are going to be styled based on what we just put inside here. Now we get inside here is just tell it how to lay things out, or not how to lay things out, how to get a hold of the thing that lays things out, which we can use to draw on later. Okay, so if I go ahead and save files and save the index.html. Okay, let's go ahead and define these pieces here then. So over here in the source, I'm going to add a new file, which I can do just by having this little button here that says new file. I'm going to name this one constants.js. Okay, so now that I've got that, I can define these variables. So I can say export const rows equals 10, export const rows equals 20, export const block size equals 30. Okay, so these are just variables that hold a number. Again, we talked about what variables before. Variables are just a way for us to store information. In this case, that happens to be a number. In other cases, that could be a reference to something on the page. It could be something more important. Okay, but this is the kind of thing we're going to be using. So hopefully, if you've done any of the Scratch videos, you're a little bit more familiar with variables. But just know that variables are a way for us to store pieces of data. Now that I've got this constants.js, I can come back here to my index.js file. And I'm going to say import from constants. Okay, so I've got some curly braces here where we can see what's going on. Now I can put the different pieces that I want to import inside here. So the things I want to import are going to be that calls, the rows, and the block size. And you can see once we've done that, then everything down here that was all red and squiggly and looked ugly is now all fixed because now it knows where those came from. Now if I go ahead and save all this, so I'm going to save the constants file, save my index file, you can see down here it starts doing stuff, and we get our Tetris page. Okay, so it doesn't look like anything special just yet because we're still trying to get everything laid out, but hopefully that's something we can see. Just noticing that for some reason it's decided not to style play button. We're just going to cheat that, and that'll give us the play button we want. Come back here and you guys can take a look at this. I'm going to go ahead and add some zeros here just so we have some information. . Okay, and that should get us just a bit more information as we're going, so that we don't have just these empty spaces. So I'll go ahead and save this now. Now we got some zeros there, so it just doesn't look empty. 10, but accidentally typed 20. We need this columns to be 10, otherwise this thing gets too wide for us. So go ahead and in your constants.js, just update that to be a 10, and everything should work out. All right, so we've got our HTML, we've got our styles, we've got our JavaScript. So far, everything's going pretty well. Got a game, goes up. Okay, nothing really happens here. In fact, if you click on it, it says not defined. Well, it does inside the website, but it won't if you're not using that. So first thing we want to do is have a game board. Okay, that's going to allow us to define where things are and how they're going to work. So what we're going to do is come in here under our source, create a new file, and name it board.js, just like you would expect. Okay, now we're going to define a class, and we're going to call it board. Now this board is going to have a grid. That grid is going to define where things are on the game. So if you imagine Tetris, okay, you're going to have pieces that are all laid out and kind of interspersed, maybe some spaces in between. This grid is going to be the thing that lets us store that information. Okay, this board is the thing that represents the entirety of our board, this black border piece here. Now, what is a class? Okay, a class is just a way for us to group information and data that goes together. So in this case, the board is going to have a grid. It's also going to have some functions that are going to make things nice for us to work with. We're going to define that inside of a class so we can kind of keep everything organized. One of those functions is going to be a reset function. Okay. Now, when we call this reset function, we're going to want to reset the grid. So we're going to say this.grid equals, we're going to say this.get empty board, and then we're going to do these parentheses and then a semicolon. And if you ever get to the point and something's not working the way you expect it to, go back through, make sure you have these parentheses right, make sure you have your semicolons right, make sure these are curly braces, not parentheses. Okay, really make sure that these characters are all exactly what you expect them to be. So this just refers to the board. Okay, so we're going to reference the grid here, and we're going to set that equal to this get empty board. So this is known as an assignment. This grid is still just a variable, just like we're going to use the same. Okay, and we're going to call get empty board here. We don't define get empty board yet, so let's go ahead and do that. Okay, and then we're going to use a return, which means when we're done here, I want you to give whoever called this piece of information. And we're going to use the array.from method. Okay, now array.from is going to let us create an array. Now an array is just a series of pieces of information. Okay, in this case, it's going to be just numbers, but it's going to be just a collection of numbers or other pieces of data, but in this case, numbers. And it's just a really convenient way of storing that information. Okay, before we do that though, we're going to go to the top of our file, and we need to import curly braces again from constants. Okay, and just like we did before, we're going to import rows and columns. Okay, because we're going to use them down here. So inside our array.from, I'm going to give this an object. This object is going to have a length on it. And I want that length to be rows. So this is just a really shortcut way for us to create an array of a certain size. So I'm going to tell it that I want to create an array from this, where it's this long. Okay, there's a length with rows, and that's going to give us an array of that many pieces. And you can see here, this tells us that rows is 20. So this would give us an array with 20 things in it. So it's just a collection of things, and there are 20 of them. Now I'm going to tell it what those things are. I'm going to do a comma, and then I'm going to pass in a function. Okay, but this is a fancy function known as a lambda. And a lambda is just a way of defining a function without having to use any extra characters, any extra words. So my lambda is going to take this array. I'm going to create another array that is calls big. Okay, this is going to be 10 items because calls is 10. So this array here is going to be 10 items long. I want to fill that 10 items with zeros. Okay, so this is a bit of a fancy piece of coding. So let's look at it again. I want this to be an array, and I want it to be an array of 10 things, and I want it to fill that array with zeros. So what this right here is going to do is give us an array with 10 zeros in it. So it's just a collection of numbers, 10 of them, and they're all zeros. Okay, now the tricky part comes from this thing being used with this array.from. So what I'm doing is I'm creating an array from this thing right here, which is a 20, and I'm filling it with this array, which is 10. That's going to be confusing. What that's really doing is giving me an array of arrays. Okay, so now I have this array which has 10 things in them, and now I have 20 of those arrays. Okay, so it's an array of arrays. That might be a little complicated, but if you ever go look up a matrix, okay, at some point in algebra you're going to be doing matrices, that's all we've defined right here. And it will look something like this. So if you think of this bracket, okay, so this is how you would define an array, and you can see it's just got 5 zeros, and they're inside these square brackets, which is what we would use to define an array. Well, that's great that I have 5 of them, but what if I needed to have more than just that? Well, I could add them to this one array. Well, let's say I wanted it to look like a table. Okay, well, what I can do is put another bracket here, and another bracket there. And I'll just do this to get it to stop complaining. All right, we're going to delete this in a second, but this is just to show you what this is going to look like. So you can see we've got these brackets here. And I'll just go and line everything up. Okay, so each one of these rows only has 5 things in them, and then I've got 5, I guess each one of these columns only has 5 things in it, and then each row, there are 5 rows as well. So overall, I've got 25 things, but I can organize them into rows and columns, okay, and it makes this grid. So that's what this little piece of information, this little piece of code here does, is it creates a grid like that, except rather than being 5 by 5, it's 10 by 20. Okay, and that's just to represent this thing being 10 by 20. That's how we're going to represent this board. So anytime we want something to show up here, we're going to put a number inside our grid, and that will tell it to draw a block there. Okay, so we're just going to use this getEmptyBoard function to create that for us, and then we're going to use that to assign our grid. So our grid now is going to be 10 by 20 grid of numbers. Okay, so now we can come back here to our index.js. We've got all of our information for our canvas, but we haven't done anything with it. So first thing I want to do, well, we're using let, is define our new board. Whoops. And actually, oh, it did it for me. I'm going to undo that so you guys see what happened here. So when I say new board, Code Sandbox and Visual Studio Code will do this as well. It's smart enough to know that this board comes from this board.js file. So if I tell it to auto import, it just puts this import statement in here for me so that I don't have to do it. It's a really handy piece, but we need this to be here. So before we can use this, we have to do an import on it, but it's gone ahead and done that for me. So now I can create my new board. So I've got that. Okay, and lastly, I need to define this play function. And this play function, if you remember over here in our index.html, on our button, we said when this button is clicked, call play. Okay, well now we're defining what that play is, and so now we can tell it what we want it to do. So I can say board.reset, and then I can just do a console.table for our grid. All right, so I'm going to say this, like this. It's going to redo that. felt like that was necessary to explain TypeScript, so I went with JavaScript for this, and didn't think this would be an issue. So just make sure we're going to add a new file. You can see it's just right here alongside our index.html and package.json. So just a new file, and it's .babelrc. Okay, this file is going to tell Code Sandbox how it wants to run our code. So go ahead and put this information in that file, and everything should pop up and run just fine. Sorry we didn't do that earlier, but we want to make sure that we have this piece in there. Okay, the next piece we're going to change is just come in here to this button. We're going to change this to an ID of play button. Okay. I thought that by doing this the simplistic way, it would work better, but turns out that's not the case with the JavaScript again. By doing this with JavaScript instead of TypeScript, it's a little bit more strict on how it does things. So yeah, we're going to come back in here to our index.js. Okay, and in this play button here, we're going to come up here and do another one of these. So we're going to say const play button. We're going to say document.get element by ID. And then we're going to say play button. And now we have our play button. Okay, now if I come down here, I can say play button dot add event listener. And then I can give it that play function. What we did is, again, using the same document piece, we went ahead and got that play button, a reference to it. Then down here, we're adding an event listener. The event we're listening for is a click. So when I come over here and click on something, that's going to fire an event. When that happens, it's going to call this play function. Okay, which will come in here and go ahead and run that information. Go ahead and make that change. I'm going to save this here. Come back to our index.html. Okay, all we did is change right here where it said on click equals play. Instead, we're just going to say ID equals play button. Go ahead and save that. Okay, it's going to come in here and reload everything. Now when I hit play, okay, nothing happens. That's supposed to be the case. But if I come in here and look at my console, make this a little bit bigger. And here's the error from before. You can see this table right here. This table goes 0 through 9, then 0 through 19. So that's 10 by 20, which is our grid right here. Okay, remember we did 20 rows, 10 columns. Close these. And that's doing that because in here on our index.js, when I click that play button, if I do it again, you can see there it's got it twice now. Clicking that play button tells it that it should fire this click event. And we told it to run this play method when that happens. When that does, it resets the board, which assigns that grid of 10 by 20 to our board. And then we're telling it to log that out to the console as a table. And you can see exactly what's happening. Okay, so after all that, we finally have something that does something, which is to click that play button and we get some information down here. Go ahead and close that console. There. All right, now that we have some things going, we need to define our Tetris shapes, okay, the things that we want showing up here. Now there are a few different Tetris shapes. They all have names that are named after letters. Okay? There's the I, the J, the L, the O, the S, the T, and the Z. Each of those are only 4 blocks big. And they're just those 4 blocks being rearranged in different shapes and sizes. Well, all same sizes, different shapes. Okay? So we want to be able to represent that same series of shapes inside of our game. We're going to come in here to our source. I'm going to say new file. And here I want to call it shape.js. Okay, and just like before when we had our board.js, now we have our shape.js. So we're using the different files to represent the different pieces that we want. Okay, so I'm going to say export again, class, piece. And now we're going to use this class to represent the game pieces as they come down. So we've got an x coordinate, a y coordinate, a color, shape, and context. Okay, so these are all things that our pieces are going to have. The X and the Y just tell it where on the grid it belongs. The color, of course, tells it the color. And the shape is going to tell it what shape things should be in. So if it's that straight up and down line, or if it's the one that looks like a short little T, that's going to be our shape. And then this context is going to be the game context so that we can draw these pieces. Okay, now we're going to create another method, and we're going to call it constructor. We're going to make it look like just all of our other methods. And you can see right here, this CTX, this is going to be that same CTX that we get over here. The first thing I want to do is say this.ctx equals CTX. Okay, and then I'm going to call this.spawn. We haven't created our spawn method just yet. We're going to go ahead and do that now. So spawn. There we go. And you can see all of these functions have exactly the same structure. They have a name, and then these parentheses, and then these curly braces. That's just the way functions are defined inside JavaScript, inside of a class. Okay, this constructor one, this is a special one. This is going to get called every time we create a new piece. Whenever we have something new pop up over here, that's going to be called. And this spawn method we're going to use to actually create the piece itself. So for now, we're going to make this just all be the same piece so we can see something happen on our board. Later, we'll update this to be a different piece each time. But first thing I'm going to do is say this.color equals, and I'm just going to say blue. Okay, then I'm going to say this.shape equals, and here we're going to use another one of those grids. I'm going to have my square brackets. I'm going to have more square brackets. And in this case, I'm just going to have 3 numbers. I'm going to do another one. Oops. Then I'm going to do my last one. Okay. Now, if you look closely at this, you can see which shape that's going to be. It's going to be the shape that has the down and then the long side on the bottom. Okay, so it's going to be this one's the J. You can see it's kind of the twisted, like if I were to twist this, the direction would be of a J shape. Okay, then I'm going to tell it where to start. So I'm going to say this.x equals 3, and this.y equals 0. What that means is the y is 0, so it's going to start at the very top, and the x is 3. So if this is 10 columns, it means it's going to start on the third one, just going to put it about here. Okay, so that's going to give us our shape. I'm going to go ahead and save that. Then inside of our index.js, inside of our play method here, I can get rid of this console piece because we don't need to see that anymore. And I'm going to say const piece equals new piece. And again, Code Sandbox is just smart enough to know that if I mean piece, I probably mean this one, and so it can import that for me here. Okay, so I'm going to let it do that. And notice I just did this import statement right here, import piece from shape. Okay, so it's just doing that for me. If it doesn't do it for you, if you're using something else, you'll need to add this yourself. Okay, so we need to have this import up here. So now I'm going to need to give it a context, and the context I want to give it is the game context. And now I have this piece. Okay, so now I can call piece draw. Is that what I called it? I already forgot. Spawn. Well, actually, I don't need to call that because the constructor is doing that. Okay, so I can say board dot piece equals piece. Okay, so now I can come back over here. I need to add that piece to my board. Okay, so what we've done is when this play button gets hit now, we're going to reset our board. I'm going to create a new piece from this game context, and then I'm going to give that piece to our board. We're going to do things a little bit differently as things come up, but this is how we're going to do it now just to get things started. So, have all this going. Okay, we should see a piece pop up. So, actually, one thing we do need, that's that draw piece. So let's come and add that in. I was hoping we didn't yet, it would just work, but that's okay. So we're going to say piece.draw. Come over here to our shape file. We're going to define that draw method. Draw. Okay, so first thing I want to do is say this.ctx.fillStyle equals this.color. And that's going to tell it the context that I want to fill whatever I draw with this color. You can see I'm defining that color as blue up here. And I can say this.shape. And shape, you can see, is this grid. Okay, so I want to say for each row in my grid, I want to do something. The thing I want to do is that for each row, I want to do another for each. In this case, now it's going to be this value, and this is going to be every column within each one of these rows. So I can say if my value is greater than 0, then I want to say this.ctx. I want to create a rectangle. So I'm going to say fill rect this.x plus x, this.y plus, plus y, 1, 1. Okay, so let's explain what's going on here. I told it that I want to fill whatever I draw with whatever color this thing is supposed to be. So in this case, that's going to be blue. Whatever I draw, I want it to fill with blue. Then I want to take my shape, and I want to go for each row, which is going to be each set of this 3, and then for each value, for each column, it's going to be this one, this one, this one, and this one, this one, this one, then this one, this one, this one. Okay? So for each of those, if the value is bigger than 0, so you can see I've got some 2's up here, 2's are bigger than 0, then I want to draw a rectangle. That's what this right here is going to do. The rectangle is going to be located at this.x, as you can see is 3, plus x. Okay, well, each time through this for each, x is going to be 1 bigger. So the first time through it's going to be 0, the next time through it's going to be 1, the next time through it's going to be 2. Okay, so first time through it'll be 3 plus 0, which is 3. Y is going to be 0, so y plus y, again, first time through, 0, 0, 1 and 1. Next time through, this dot x will be 3, x will be 1, so that's going to be 4, and so on and so on. This is going to draw our shape onto the board. Okay, so when we call this dot draw, that's going to go ahead and draw our shape out here. So I'm going to say this, save our index.js. It does its transpiling modules thing, and now we get our board. Okay, let's do a quick recap. So we have our game board, and this game board represents everything inside here. Okay, all the locations inside this black square. Then I have this button. When I click play, it's going to come in here and reset that board. I'm going to create a new piece, and I'm going to call piece.draw. Okay, inside my piece class, when a new piece is created, I store the game context, and then I give it some values to start with. These values here are going to be blue. I'm going to give it the shape that I want, and then a location. Then when draw is called, I tell it I want to fill it with whatever color I currently am, in this case blue, and then I'm going to go through each one of these pieces inside of my shape and draw a box for each one. And I wish Code Sandbox didn't format it for me. I'd like to leave these as they are. And so you can see where the 2's are. That's the exact same shape as over here. And if I want to change this to a different color, I can do that as well. Let's give it a shape that doesn't really exist in Tetris, just for some fun. Okay, now, see if you can guess what shape that's going to be just based on what the 2's are. Okay, I'll go ahead and pause for a second and let you guys think about that. Okay, hopefully you have your guess. As soon as I hit save, it's going to put everything on one line again. Lose that, but let's see what shape we get. Ready? There you go. You can see it's this red X. And so whatever shape we put into this shape over here is what's going to be drawn over here. Whatever color I put here, that's what's going to be drawn over here. I can even do some fancy stuff, I believe. Nope, that's not going to work. You can do your typical colors. Let's do this. Not sure if that'll work or not. Yep, it does. So we can use the same colors that we have here in our styles. Okay, that same format, if you're familiar with those. All of these should work. Okay, we're going to move back to our shape file. We created the draw method. Now we're going to create the move method. This is going to let us change the position of our shape. We're going to take as a parameter a variable, I'm going to call it P. This is going to be another piece that has a position. And this is going to let us actually change the position of our shape by updating the values in our shape. So we're going to say this.x equals p.x, this.y equals p.y, and that's going to actually move the piece left and right for the x, up and down for the y. It's going to use these pieces up here. It's going to move it on the screen for us. Let's go back to our constants. Now we need to define a couple of things in here in the constants file that are going to let us update things. So first we're going to do is define a new thing. We're going to call it moves. This is going to be a map that's going to let us track what the moves are for our game piece. A map is just something that's going to let us, map that something's going to happen. It's going to take a piece of input. It's going to move things to a piece of output. It's going to let us map different things. So when we're over here, it's going to let us move our piece up, down, left, right, depending on what thing was pushed. Okay, so this piece right here, we're going to let that move, and that's going to let us do with the left, the right, the up, down. In order for that to work, though, we need to define a new piece, which is going to be called keys. And keys is going to be the thing that tells us how to take what the user pushes and actually translate that to something that's going to work. So when they push a key, then that's going to let us actually move the piece left and right. So we're going to export under const. We're going to call that keys. And it's going to be another map. And the first we're going to do is we're going to map it to left, and left is a 37. Right is a 39, down is 40. Okay, so when you press a key on the keyboard, it actually sends a signal to the computer, and it tells it what key was just pressed. In this case, that happens to be numbers. Okay, so we're going to use that information, those numbers there, to tell us what key was pressed, whether left, right, up, down. Well, just left, right, down in this case, we can map later. We're going to use that to map it in our moves piece, to then tell it what the actual game should do with our keys. So inside here, we're going to say key.left. We're going to use the left key first. Okay, we're going to use this as a function. So that function is going to be a parameter of p. And here we're going to use a parenthesis and then a curly brace and this dot, dot, dot. We're going to say p, and that's going to take all the values in p and keep them the same. But then we're going to change the x value. In this case, we're going to say x is p.x minus 1. We're moving left. So minus 1 is going to be left. You can see the dot, dot, dot p there. That's going to take everything else and leave it the same. So it's only this x value that's changed. We're going to use the p.x to do that. Okay, so that's going to take our value and move it left, our piece, and move it left. So when you push the thing, we're also going to move right. So we'll do key.right. It's going to look exactly the same. We're going to have our p, and we're going to do the same thing, the dot, dot, dot p, except this time, rather than x is going to be p.x minus 1, it's going to be p.x plus 1. And that's going to let us actually move it right. Last one is going to be key.down. That's going to take the down key. And so this time, rather than the x being something that we want to track, we're going to use the y. So in the dot, dot p, the y is p.y minus 1. And that's going to let us actually move the y piece. Okay, so with this, we should be able to hit our keys over in the game. That's going to let us move the piece around using the keys and the moves. So we can start using that to actually make the piece move over in our shape file here. All right, so it looks like for some reason desktop video didn't record. that little section. So just quickly go over what we did. Inside of our index here, just make sure we got everybody caught up. We're looking for our key down event, and that's going to watch anything that's going to be something we care about. So if somebody presses a key over here, that's going to trigger this method so we can actually run something. Next thing we're doing is looking to see our inside of our moves, is there something that we care about? If we have an entry inside of our moves map, so we want to do something with it. Do, we're going to come here, cut up the event, we're going to do all this event, we're going to get the new piece. Okay, so we're going to check to see if this is a valid position. Going to, if it is, we're going to move our piece to any position. We're going to clear out everything inside of our game area, which like I said is not going to be doing forever. For now, we're going to tell it to redraw the piece that we want. Okay, it's over here inside of our board. We created this valid function. So valid is what's going to return whether or not this is a valid position for this piece to be in. When we get the new piece, we're going to say, all right, we want to look at the shape of this piece. So then it's just going to be whatever shape that piece happens to be. We want to say, all right, since this is a table, a 3x3 table, we want to look at every row, and we want to look at the different Y components of that. So in this case, we're going to have this column, I guess, sorry. No, this column, this column, this column. And for each one of those, we're going to need a row. Nope, let me say that backwards. So this row, this row, this row, that's going to be the row, and it's going to be the position within that row. Then for each row, we're going to say, all right, I want to get the value and the difference in the x. So again, just going to piece of that particular row in the table. So we're going to say, all right, take the new x position for our this new piece that we're trying to validate, add it to whatever the current x coordinate is, for whatever piece we're on. So if we happen to get this on the bottom piece here, okay, if we move the right one, then x is going to be added one. So here, otherwise it's going to be back one, could be left, could be down one, could be drop one. Wherever they've moved the piece, we're going to take it and say, all right, this new x coordinate, we want to check to see that that's what we're going to create using the same with the y piece here. Then once we have our new xy coordinate for a given spot inside this piece, we're going to check to see, is this an empty value? So we're going to look at our shape, remember our empty values are zeros. So if it's an empty value, which in this case is a 0, then we're done. That's good enough. It's a valid piece, but it's empty, so we don't actually care. Otherwise, or we want to check to see, is the x inside the walls? We have our walls here. We make sure that our x position is between those two, and our y is above the floor. Okay, so we have our y down here, our floor down here, we make sure the y is above that. Otherwise, it is all on the screen. Okay, so this is what we ended up creating. Again, I had some video difficulties, so I didn't actually record typing this, but this is what we created with the value. We're going to say is empty. Okay, it's going to pick a value. Once we're inside here, we can just say, all right, whether or not this thing is a valid piece, we can do this. So again, let me just point it out. So here we have 2s, we have 0s. 0s. Okay, so you can see these 2's right here form the shape that shows up on our screen. So the 0s are pieces that don't get rendered. So there's nothing that shows up in these 2 spots or this entire row down here. So anything where there's a 0, that's going to be the spot where we have an empty piece. Because that's what we're checking for when we look at these empty pieces, whether or not basically we have a 0. Okay, we also want to look at the, well, so there's this. So turn value equal to 0. Next, we're going to do the inside walls. And we're going to take an x value. We'll make sure that the x is within the x position. So we're going to say return x is greater than or equal to 0. Okay, because 0 is going to be this left wall over here. And x is less than a number of columns, which in this case is is 10. Oops. 10. Okay, so basically if the x is bigger than 0 or equal to 0, then it's going to be from here over. And if x is less than columns, which means it's going to be from here to left, then that means it's within the walls. Okay, it's a very simple way of checking that. Lastly, we're going to look to make sure that it's above the ruler. And all we're going to do is check to see that the y we're given is less than or equal to the number of rows. As our y goes down, okay, it's going to get bigger and bigger and bigger. So as long as the y is less or equal to the number of rows, which is defined by our bottom line here, then that is above 50. You can see rows is 20. So 20 rows within our data. So that's how we're going to define inside walls and above the floor. So now that we have that, that should be enough for us to say that the piece is valid. So that we go through and try to actually use our piece, use our move function, we can make sure that everything is running properly. So now that we've got that, let's actually let's just save everything real quick. So, okay, so everything's moving well. Okay, inside our constants, we have created our space piece here. So that's what we're taking off. Editor's note. I guess this is just going to be for me. We've added this in as first. And go. So inside our index here, everything's moving fine. We need to actually tell it to do the drop function next. So we just created the space handler, and now we're going to use that over here to make things happen. So as we're running our code, we're going to come in here and we're going to make sure we get the new keys. Then we're going to check into a special case if it's the space key. Because if it is, we want to have that piece just rock to the bottom rather than moves one key at a time. So we're going to say if our key code is space, and then we're going to do what's called a loop. So this is going to be while loop. We're going to say while current position is valid, and do stuff. So this while loop is going to come in here and say, as long as this is true, in this case, as long as our piece is valid, then I want to keep doing stuff inside here in the middle. Okay, so this is a way of doing multiple things at once without having to write the code over and over and over again. So first thing I want to do is say board.piece.move. We want to move our piece in a new position. Then we're going to make our p equal to the new position. So we're going to use moved event.pcode board.piece. Okay, just like above here. So we're going to move the piece and we're going to update it again. As long as we can keep updating this piece and have it be a valid position, then we can make it continue on doing things. We can just keep moving down. Okay. Now, if it's not the space key, then we're going to say else. Else. That's when we're going to do this stuff here. And so it's not the space key, then else. Otherwise, as long as the board is still valid, then we just want to do whatever the key was. So if it was the left key or the right key, that's not the space key. So we still want to make sure that it's valid, but then go ahead and move it if it is. Okay, so that should give us, let's say, our drop functionality. I'm going to refresh this just because last time it didn't quite work. So left, right, down, we have the space key. Up to 7 happens. Make sure I put that. Nope, 7 happens. So this is again where we get to debug and figure out what's going on. Okay, so the piece we missed to make this work is inside here, we need to be calling this last little section in both places. Okay, so I'm going to have to take this out and move it down here. So here we're going to have everything update. In this case, it's going to be just updated one time. We'll be updated multiple times because of our loop. Then once that's done, then we can draw everything. It is all working. So now we do left, right, down, and space. There we go. Here you go. We still have that bug where it's not checking that last piece. That's okay. That's time. But we should have that, and we can still move left and right. We have a left right piece close, but we'll go down. Okay, so we have our pieces here, and now we can do our drop functionality, our left and right, and everything works. So the next thing we're going to do is to work on our piece rotation. Okay, so right now our piece is just stuck in this one orientation here. And there's no way for us to rotate that. And if we run it from Tetris, then you know that one of the big pieces is being able to rotate the piece that we want. Okay, so we're going to come over here to our shape. Just for a move, we're going to call a rotate function. Okay, here's where we're going to define how we want this thing to work. So before we do that, we want to create a copy of the current piece that we have. And to do that, we're going to kind of cheat a little bit. We're going to use this JSON piece. Okay. Don't get too concerned about that. That's nothing special. This is just a library that's built into the browser. I guess it's built into the browser. We're just going to use this to create a clone, an exact copy of our current shape. Okay. Then, once we've done the rotation stuff here, we'll go ahead and return that. Okay, so to do that, we're going to use what's known as a matrix transpose. And you don't need to worry about how exactly that works or what exactly that is. It's a math thing. So if you ever go into math, you'll eventually learn what that is. They're useful. Matrices are extremely useful. But for now, we're just going to go with whatever it is, and we're going to use it to make our stuff easier. So we're going to do a for loop. So before, we did a while loop. This is a for loop. It's the exact same thing, where actually, sorry. So this for loop is going to do the same loop, but this time we're going to do it a specified number of times. Okay. So this for loop, the while loop just kept doing it as long as something was true. This one does the same thing. What we've got here is we're defining a new variable called y. We're going to say as long as y is less than the length of our shape. Okay, so remember our shape is actually this table up here. So our length is going to be 3 because there are 3 rows in our shape. So as long as that's true, do the stuff in here, and then when you're done, increment y by 1. So we're going to start with 0, do some stuff. 0 is less than 3. Then we're going to add 1 to y. Okay, 1 is less than 3, so we're going to keep doing it. Add 1 to y. 2 is less than 3. Keep doing stuff. Add 1 to y. 3 is not less than 3, so we're going to stop. Okay, this is just another loop that does the same kind of thing as a while loop, which is set up a little bit differently. So now that we have our y stuff, we have the same thing for our x. Okay, and then this is going to be restricted to how you transpose a matrix. We're going to use some special fancy JavaScript stuff here to make our lives a little bit easier. So in this case, we have our y, we have our x. Again, y is going to be 1, or sorry, 0. So x is 0, x less than y. No, x is 0, y is 0, less than, so it's done. So this
inner for loop is going to break out. And here y is going to be 1, and we're going to keep going like that. Okay, so inside here, we're going to say clone shape x, y, okay, clone shape y x equals shape, if I can spell, there we go, y x, clone shape, shape x. Okay, so this is just a fancy way of swapping positions. So we're going to say take this position, this location in our table. So let's say this is, let's say x is 0 and y is 1. Okay, so x is 0, y is 1. That's going to be x is 0, so that's going to be this location, y is 1, so that's going to be that piece there, that 2. And then also we're looking at y x. So y is 1, so that's going to be here, x is 0, so that's going to be here. Okay, we're going to take those two locations and we're going to swap them with these two locations. So this one is going to go here, and this one is going to go here. In this case, they're both 2's, but as we move through things, the next time through this will be a 0, that'll be a, next time that'll be a 0, that'll be a 2. So it's going to swap those two positions, swap the 0 and the 2, and our piece will rotate as we go around. Okay, but what we actually want to do is reverse the ordering. So we're going to say clone shape for each one. I can't spell at all. Shape. So there we go. Row reverse. And this is going to take and switch. So it's going to just move backward every one of our pieces. And you can do that in order for it to look properly. Otherwise, you're going to get a weird mirror effect. And so this will reverse everything, and then we can return our cloned piece. Okay, so now that we have our rotate function, we need to define how we're going to use that. So we're going to come back to our constants file. We're going to define a new key. We're going to say the up key is going to rotate our particular piece. Okay, now our up key has the value of, because I don't have it in front of me. Up key is 38. Okay, so now that we have our up key there, we can come in and we can tell it to rotate the piece. So here, rather than what we normally do, which is just I move everything, either the Y or the X up or down one. Instead, we're going to call key.rotate. Okay. So now we have our moves. So we're going to have this stuff here, this stuff here. Our up key, we're just adding in. So this is the new piece, the shape. We call rotate. This is what's going to run. Okay. And we're going to do all that stuff over here as we look for the up key to be pressed. All right. So what we're going to say here, this is to check to see that the up key. We're going to call the up key in our map. That's going to give us the new position. It's not the space key, so we're going to check to make sure that everything is still valid. And we're going to move it, and we're going to redraw. So let's save all. Play, make sure we don't break anything. Left right up down, so it works. Now we get our up key. Let's make sure that we get that fresh. Looks like that's what the problem is. Go left right up down. Up. Still does nothing. Alright, so we got all our stuff added in. There's one more thing we need to change. So Everything before is relied on just the x and the y stuff changing inside of our new function and our piece. This new piece is rotated, actually changing the shape itself. So the last thing we want to do is go over here into our shape. And inside new, we're going to come here and say this dot shape because we choose that shape. What that's going to do is replace the layout of our shape with whatever the new shape is. We can save that. Just because I want to make sure that works. Sometimes it needs to be good. Play, make sure we didn't break anything, so this all works. Down, well, the left right down works. I hit space now. That was the wrong key. One with the up button. Let's try that again. There we go. If I hit the up arrow now, you can see we get a rotating piece. Okay, so make sure we have the shapes being set as well as the x and y coordinates, and get to where we need to go. So we can now move our piece all the different ways you would expect things to work. So now we need to make these things more random so that it's not just the same piece over and over again, and we don't have the same color over and over again. So we're going to go over here to our constants. Okay, we're going to add a new set of constants. We're going to call it colors. Export is a const colors equals. We're going to give it a list of colors that we want to support. So cyan, which we're using right now. We're going to use the string blue, orange, yellow, green, purple, and red. And if you want to change those to something else, then by all means. We're also, though, going to define the shapes that we want to support. So export const shapes equals, and now we can define the shapes that we want to have in our system. So the first thing we're going to do is define our just a straight line. Okay, so that's going to be zeros and ones. Okay, so if you look at this as a shape, you can see it's got just all the ones across there. So the next shape we can define is going to be the shape that we've got, which is going to be the L shape. We're going to start out rotated. This is going to be the, well, this is going to be L of the shape. This is the shape. That's what we've already got. But we'll define that next. So 2, 2, 2, 0, 0, 2, 0, 0. We're going to define the rest of them. I'm going to skip ahead. All right, so we got our shapes in, colors, shapes. A couple things to note. We're going to have to write all these twos that we don't want to do that. So each shape is going to have a different number. When we do that, when we have them all bundled up right here in the basic lines and things, we know which things are which. So we know what color they should be and where they came from. So make sure you have the numbering right. So 1, 2, 3, 4, 5, 6, 7. And then you can see our different shapes. So this is just a straight bar. Okay? This is the L shape, or J shape. This is the L shape. This is our square. This is our S. This is our T. And then this is our Z shape. Okay, so we got those in. We got the different shapes. We got our colors. And notice that the number of colors match with the number of shapes. That's on purpose. We're going to use those to have each shape be its own color. So the first one is going to be cyan. Second one is going to be blue. Third one is going to be orange, and so forth. So if you want to have the different shapes with different colors, just make sure you change the ordering. So if you want to have this one be red, that top, cyan down. However you want to do it, make sure you have 7 and 7. Okay. And these aren't going to be just any color in order for it to work. They have to be valid CSS colors. For which there are quite a few. but make sure you check to see that these are valid. If you don't see anything showing up, it's probably because you put something in here that isn't valid. So make sure you've got that right. We've got our shapes and colors ready to go. So over here, our shape class, okay, our spawn. We want to remove these pieces because those aren't going to be needed anymore. Okay, and then we're going to need to get a random number. And then we're going to put some space out. Okay, and good. So inside here, we're going to remove our spawn. We're going to create a new function. We're going to call it randomize preliminary type. Okay, and there's a number of types. Okay, so this is what we're going to use to make our shape be the one we want it to be. So the number of types is going to be the number of types we have, which as we just discussed is 7. So we're going to say return math.floor. And the floor function, so if you get something that has a decimal point to it, the floor function for positive numbers is just going to basically wipe out the decimal portion. Okay, so we're going to use just a whole number. And we're going to use the math.random function. The math.random is going to give us some random number between 0 and 1. It may not sound like that works, but remember we have decimal numbers. So we have 0.5, so that's going to be 1/2. Okay, this is going to give us a, basically an infinite number of numbers between 0 and 1. We don't want an infinite number of numbers. We want 7, or whatever our number of types is. So we're going to say times number of types plus 1. What that will do, let's say random comes back at 0.5. Okay, 0.5 times 7 is 3.5. 3.5 plus 1 is going to be 4.5. And then this math.floor, pop off the decimal point next to this 4. Okay, so this will be just a way of getting some number between 1 and 7, or 0 and 7. It's going to be just a random number, a random whole number. So now that we have that, we're going to go back up to our spawn. And we're going to add in a couple of pieces here. So we're going to say this is a type ID to tell us what kind of thing, what kind of shape this is. So we're going to say this.type ID equals this.randomize the thumbnail. Okay, and then we're going to say we want a number of pieces. But we don't want to just hard code in 7. Instead, what we're going to do is we're going to use our colors array to do that. So that's going to be in our contents, and we can say we want colors. Okay, so now we can say we want to see colors dot length plus 1. Okay, so now this is going to give us number 1 through 7. And if we look back at our constants, 1 through 7. Okay, so we know which one we're going to be. So now we have our type ID, so we know what shape we are. And we're now going to say this dot shape equals, and we're going to need to do another import here. There's the colors and shapes, but I'm going to go ahead and let the environment do it for me. Again, so just to show you how this automatically pops up shapes for me. If I hit tab, there's that put in shapes in the import and finish that for me. So, handy thing. You say square bracket with type ID, and that's going to give you the shape that I want. And then it's a this color equals colors. And the same thing, this type ID. And then this x equals 0, this y equals 0. Okay, so now we have this, it's going to spawn a random piece each time, rather than just being the same piece over and over and over again. Okay, so actually, just so we can see it a little bit better, I'm going to push this into the middle more. So I'm going to say B, A, 3. Save everything. Get this removed. Okay, so we are play. We get our blue L the J shape. And we're not clearing everything when we draw. But you can see there's our Z, there's our T, actually, that was the Z, the other one was the S. All right, looks like we had another loss of data. My screen capture decided not to capture that last segment. So we're going to have to go over a few more pieces again. But that's okay. So inside of our shape, okay, we want to add in the last few pieces to make it so this works. We're also going to add in the set starting position. Okay? So we're going to use this shape, the type ID, to determine where it should start. So if any shape is, if any shape other than 4 is started, we want it to be here. Otherwise, we want to move it left one so that they all start in that same position. Okay, so set starting position here, everything else should be covered. Instead of our constants, all this looks the same. We just added in an extra empty piece here that's never going to be used, but we want to just so the numbers line up. Okay, our index, we removed a few things. So we removed all the setup pieces up here. And we're going to move those into the game. We want the game to be responsible for doing everything that it needs to do. So now we're going to take this game context, we're going to pass it into the board constructor. And for now, it's going to pass in null because this piece we aren't using just yet. So we're going to define this new reset game function. But now all it's going to do is reset the board. And our play function is wiped out. We're just going to call reset game. And we're also going to call this animate function. Okay, so animate for now is going to clear our game board. And then it's going to call board.draw. Okay, so those are the new pieces for our index. Again, sorry, the capture got erased, but this is where we left off. So we come over here to our board. Okay, we have a new constructor, which is with two contexts. One is the context for the game area, the other one is the context for the next piece area, which we're not using yet. So we're going to store those in some variables. Then we're going to call this init function. Okay, and here's what we're going to do what we were doing over here inside the index section. So we're going to call context.canvas.width is number of columns, canvas height, number of rows, and we're going to scale everything to this block size. That just makes it so everything is a one-to-one for the scale. Okay, so we've got that stuff over here, so now the board is the thing responsible for the creation of everything. It's going to create the new pieces. It's going to call that set starting position for that piece, so it gets to where it needs to go. Everything's going to be lined up. Okay, so we go over here and run it. Notice now we get everything nice and clear. The board displayed where we want it to be. Okay, so everything is running exactly what we want it to run. Again, sorry, I got all the voice for it, but none of the desktop capture worked for that particular section. So we lost all the actual code. And hearing my voice is annoying enough as it is. We don't want to have to do it without actually seeing what's going on. So go ahead and update your stuff to just look like this. There's the board. There's the index. Okay, so that looks mostly the same. Here's our constants. Make sure we get that empty space in here. And then our shape. So it should all look like that. I'm going to go up a little bit so you can see it up here. Okay, so it should all look like this. Okay, so now that we have all this set up, we can go ahead and start making our game actually do stuff. So to do that, we're going to use our animate function, which we have defined over here in our index. Okay, and that's going to control how everything is rendered inside of the game. So when our game is ready to update, we're going to use this animate function. Now the thing about games is they have what comes in game loop. So this game loop will allow us to determine what should be happening. So it's like the timekeeper of the game. So as your character is moving across the screen, as you're trying to look at something, whatever game you've got, it's going to be a game loop. That loop is going to redraw whatever needs to happen as it does that. Okay, so inside of our animate, we're going to modify this now to get a new loop piece. So we're going to take this to the passed function or passing parameter, which is going to be now. So whatever the time is now, we're going to use that to determine what should happen next. Okay, the next thing we're going to do is keep track of what has happened otherwhere or other places in the game. So we're going to be using a time piece to do that. And time is going to keep track of things like how much time has elapsed, what the last piece was that did something. It's going to be the piece that does all of our time keeping. So inside reset game, so we're going to come up here and say time. And inside reset game, we're going to say time equals. We're going to put an object. We're going to say we want to do start 0, elapsed 0, and level. Okay, for now it's just going to be 1. We're going to use that level later if we want to change levels here, make things faster, that kind of stuff. But for now, we're just going to leave them locked to 1. Okay, so then we have that time piece. We have a start and elapsed, a level. This is where we got that. Like that. I don't know why it puts on button like that. Because it's assigned a value but never used, where the value is never read. Okay, so down here inside of our animate function, now we have our timekeeper, or an object that can handle time for us. We're going to use it to update some things. So we're going to say time.elapse equal to now minus time.start. Okay, so whatever now is, however long it's been, we're going to say take the starting time. It's now, subtract the starting time. That's how much time has elapsed. So if we started at 2 o'clock, and it's now 2:15, as in the elapsed is going to be 15 minutes. Okay, so now we know how much time has elapsed. So the next thing we want to do is use that time to determine whether or not we have our game over. Okay, so we're going to use this to be sort of a timer for our different piece. So we're going to say if time.elapsed is greater than, and then here we want to figure out how much time we want to give them to play the game. So you can change this to be whatever value you want. If you want it to be a short game, you can use a small value. If you want it to be a big game, you use it to be a big value. Okay, I'm going to start that by saying 1,000. And that's going to basically be 1,000 seconds. And so, well, I guess 1,000 milliseconds, really 2 seconds. Anyway, I'm going to set to 1,000. So just know you make this number bigger, it lasts longer, if the number smaller, it's a shorter game. So use whatever time you want. Okay, so for a longer game. And we're going to use that to say, all right, if our elapsed time is bigger than that, then we're going to say our time.start is now. And so just like we're stopping over. And then we're going to say game over. And the verb is going to be return. So we're going to reset our start. So just basically say that we're past where we want to be. We're going to call this game over function. Now this game over function is going to be important because we're going to use that in a number of different places. So we're going to come down here and create it. There we go. Alright, so inside here, we're going to do 2 things. We're going to do a few things, but first thing we're going to do is put the game context. We're going to say field style equals black. And we're going to tell it to fill a rectangle. At that location, there's going to be a black box. And we're going to say the game context of font is 1 pixel Arial. And then we're going to change the context by the color to be red. And we're going to say game context of the text. So what this is going to do is it's going to say set this facade of black, then make a rectangle. So when we do that, because we set the facade of black, we draw a black rectangle on our board. Then we're going to set our font to Arial, one pixel large, that's one Arial font. Then we're going to change the facade to red, and tell it to fill text with game over. So this will be red text at that location, which is going to put game over inside the black fonts. Get up to its game over, this is what's going to happen. So when our time has elapsed, we call game over. Otherwise, it's going to do what we've already done, which is quit a game, tell the board to draw. Okay. The next piece that we need to do is we're going to use the browser to build up how we want the game to run. So we can manually tell it that we want to update the game every so often. Okay, but we don't really want to be in charge of doing that because the browser may not be fast enough to keep up with us, and that's going to cause some performance issues. So instead, what we're going to do is we're going to use something that the browser has, which is known as request animation frame. And request animation frame is going to be what we use to basically have the browser run things for us. So once we're done rendering something, the browser will draw it onto the screen. Once that's done, then the browser will say, okay, I'm doing that. Now I can go ahead and run the next thing. So this will allow us to get a number of, so if you're familiar with the term frame rate, it's going to allow us to target a frame rate that the browser can keep up with, but also allow us to do drawing at a rate that actually makes sense for things. So inside of our animate function, we're going to use that. So we're going to have another variable here. It's going to be called request ID. And then here, inside of our animate function, we're going to create a rectangle that we've drawn. The game is here. Then we're going to tell the board we want to redraw what's on the board. Then we're going to say request ID equals window dot request animate frame. And we're going to tell it that when this happens, we want it to call animate function. Okay, so this window is going to be the actual window, and we're going to call this request animate frame. So this is going to allow us to, like I said, have a targeted frame rate that actually makes sense for the actual game. So we run as quickly as possible, so we're not dropping frames, we're not having to run things that make sense, we're not overloading the browser to still get things to happen. So when the browser says, hey, I'm ready to draw the next frame of the game, then it's going to call this animate function. It's going to give it the correct time. We're going to run this logic to say, hasn't spent enough time yet. We have, game over, otherwise, go ahead and draw everything you need to. Okay, if we're in game over, we actually want to stop this request animate frame. So down here inside game over, before we do this display to the last thing, override that, we're going to call window.cancel animation frame. And here we're going to use our request ID to do that. That's going to tell us, hey, I'm no longer interested in knowing when I can update it, just I'm done with all that stuff. And so the browser is going to stop trying to call animate, stop trying to make it run. Okay, so with those two lines and our variable, our request ID, If that finally got run, now we have the ability to actually have the game run essentially for us. Okay, so now we can have things like the game, if we need to tell it to pause, or we need to tell it to stop or something, we can do it. We can do that simply by telling it to cancel the animation frame, in which case animate never runs and we never get anything updated. Okay, because our board.draw is happening down here, and it's never going to do anything. Okay, so now that we have that, we can update the rest of our stuff to use pieces that we actually want to happen. So inside our key down, let's just double check. We've got our stuff here. Our space button is going to work, so we get the hard drop. That's going to move our forward, Okay, but this piece down here, this is what we want to remove. And the reason we want to remove it is because we want the animate piece to handle that for us. So we don't want this eventless to do anything. We want this to handle it. So let's go ahead and remove that. Okay, and so now we're just left with the function that's going to be called depending on which piece they pressed. Then we're going to check to see was that the space key. If it was the space key, then we'll just go ahead and do the hard drop. Okay, otherwise, whatever key it was, just go ahead and tell it to move, and that's it. So the piece will move, but we're not going to actually update the screen until we're ready to do that. Okay, so the next piece we want to do is going to be our game moving the actual piece. Okay, so inside here our board, we're going to create a drop function. That's going to be used to drop the piece, the current piece, just down one. So that's going to cause the thing that's just moving inside down each time the game happens. So inside drop, we're going to say get our new piece. And we want to move our bring our moves to my constants. And we want to bring in our keys for constants. We're going to do the down function because when the piece moves down, it's exactly the same thing as if they pushed the down button. Okay, so now we have our new position, our new piece. It's going to move down one. And we're going to check to see if this piece is valid. Then go ahead and move that location. Okay, do the same thing we did back here when we hit the down or anybody. Okay, so if it's valid, go ahead and do that. If it's not valid, though, then that means we are in a state where the game needs to stop. I guess not to stop, but the drop needs to stop. You can't move down any further because either we hit the bottom or we hit another piece. Okay, so we're going to call this .freeze. We haven't created yet, but we will in a minute. And we're going to call this .clear lines. Okay, so freeze is going to be the thing that sort of solidifies everything down here at the bottom. Clear lines is going to be the thing that looks for any lines that go all the way across and then removes them. So we'll write those two functions in just a second. We're going to say if this.piece y is 0, then we're going to return false. What this means is if y is 0, that means we're basically right up here at the top. Okay, which means we've tried to move down and we can't. We're at the top, which means game over. Okay, so we're going to return false. If though that's not the case, then we can move on to our next piece. Okay, in this case, we're going to return true because we haven't moved around any of the next piece yet. We'll do that next after we get the game moved running. That's what we're going to do. So we're commenting here for ourselves. Okay, next piece. Okay, for now, we're going to return true. Now let's create those other two functions. So let's create the freeze function first. Okay, so again, the freeze function is going to go through and just tell it that we want to stop all the pieces, just basically bunch them up down at the bottom. So we're going to say this.piece.shape for each. Okay, so we're going to go through and for each row of our row of our shape, and we're going to say row for each, which is going to be for each column of our shape. So the entity there, we're with the value, and we're going to say X position again. So we're going to say if the value is greater than 0, so basically if there's an actual piece there, then we're going to say the context style needs to be whatever our value is, which again, 1, 2, 3, 4, 5, 6, 7, that's it. And maybe bring in our colors. Maybe tab keys like those. Okay, so we're going to set that fill style, so it's going to draw whatever color we want. Then we're going to say context rect. So we're going to draw that rectangle x, y, 1, 1. And so we're going to be drawing each individual square as we get to it. That's just going to allow us to draw the different pieces down here, even though they're no longer part of an actual shape. People arrange the stack or what have you. And so this is going to bunch everything up for us, just at the bottom of the screen. The next piece is going to be the real lines piece. And again, this is going to be the piece that goes through and says, all right, where do I have a line going all the way from the left to the right? I want to go ahead and remove that. I'm going to say line is equal to 0. Now I'm going to say this.grid for each. We'll do the same thing with the point. So if we row, and I'm going to say if row.every, so that means basically if everything in this row is the case, value is greater than 0, and that means this is a solid line. So we've got the row, this will be just each row of stuff in here. If every value in this row is greater than 0, that means it goes all the way across. Because remember, zeros mean empty squares. So if everything is greater than 0, that means there's something there in every case. So then we want to say lines plus plus, okay, and then we would say this.grid.splice y. And what the splice function does is just removes that piece from our table. So we're going to do that at location y. We remove just one row. Okay. And lastly, we're going to do this.grid.unshift array cause fill 0. Okay. So what we've done is we've taken our grid and we've removed this row. The problem is that our grid is meant to be a specific size. Okay, so you can see the empty board right here. It's meant to be a size of number of rows, as you can see it's 20. And if I splice one out, now I've only got 19 rows. So what I want to do is actually take and put an empty row of zeros back in that place. Okay, so now all of our stuff is going to be what it should be, and that's going to cause us to actually shift everything down one. So when we remove that row, everything above it's going to move down one, with the empty row on top, and there we go. All right, so now that we've done that, we can check and see, all right, if we're not doing our score stuff just yet, so we're going to, before we go back, we're going to say calculate score. Okay, this is complaining, saying we can use, so we're going to set that to const, and then we'll just say if line is greater than 0. No, that's a flat, because there we go. So we'll put this here just the warning goes away. For this, we're going to have to calculate the score based on how many lines they've cleared. We're not doing the score just yet, so we're not going to do that just yet. So we now have those pieces. We can freeze our board and clear lines, which is what's going to happen inside of our draw. Okay, the last thing we want to do is be able to draw the game forward. So down here after this draw function, we're going to create draw forward. This is where we're going to get everything running to draw the board itself. So let's say this grid for each road y. And we're going to say for each row, value x. Okay, if the value is greater than 0, so again, remember, zeros are empty spaces, so we only want to do this if there's something there. Then we're going to say context, go to style, equals colors, value. That's going to change it to whatever color this piece happens to be. We can draw a rectangle, y, 1, 1. Okay, so just like we did up here, where we're freezing the board, we're going to draw the board in actually the exact same way. And that's because I was wrong. Oh boy. This is wrong. Sorry about that. Okay, up here in the freeze. We don't want to draw over the wrong thing. We actually want to just change things. So we can say this.grid y plus this piece dot y. And then we're going to do x plus this dot piece of x gives value. So what this is supposed to do, and I should have this earlier, is inside of our grid, if the value actually exists, then we want to take our grid and at this location, we want to put that value into it. So we're basically taking wherever that piece is, we're transferring it over to our grid. So this is what's going to take, as we have the pieces falling, if they hit something else, they're going to get locked into that position. That's how we're going to do that, is take those values and transfer them from the piece to our actual game grid. And that's going to cause it to be there forever until the lines as moved. So, sorry, I just got that earlier. So, freeze brings that over into our game grid, draw board, then draws the board. Okay, the last quick piece we want to do is over here inside of our index of our main game code. Okay, actually, no, that's going to be inside of our board. So inside our draw function, we want to draw not just the game piece, also the board itself.
Okay, so the next thing you're going to do is to build the next piece functionality. So that's going to be where we show the next piece here, and then when this one is done, it shows up at the top. So to do that, we're going to go back to our board.js file. We're going to build the getNewPiece method. And this piece is going to give us the functionality we need to make that happen. So I'm just going to put that down underneath the draw method here. We're just going to call it getNewPiece. All right, so first thing is we want to get the new piece, and we're going to say this.next, because it's the next piece, equals new piece. And if you remember, our piece object requires that context. Because this is the next piece, we actually don't want to give it the game context, because we don't want it to draw there. We're going to give it the next context, and it's going to draw on the next piece. So the difference is the game context is this right here. The next we haven't been able to see because there isn't anything in there, but it's over here and it's going to show what the next piece is. So to do that, we're going to do this.ctxnext, Now we have our next piece that can be done. So next thing is going to say this.ctx next. Okay, now we want to clear everything out just like we were doing with the when we clear the game board. Okay, remember how we clear everything and then we redraw it? Do the same thing here. So we're going to clear out the next area, and then we're going to tell it starting location, which is at 0 and 0, and then we want to tell it to clear out basically the entire thing. So we're going to use the canvas's width and the canvas's height. Whoops, no capital. To do that. Okay, so that's going to clear out the entire box. So we're going to go from the top left corner to the bottom right corner of that box and clear it out. Okay, then we're going to tell our next piece to draw. Okay, so that will give us our next piece, which of course is going to give us, like I said, that box over here. Next thing we want to do is come back up here to our reset method. Okay, and inside our reset method, we want to get the next piece. So here's what we're going to do: this.get new piece. Okay, so I'm going to collapse some of these so we can see a little more easily, since we're not going to be using them. For all we've done. So here's our get new piece. Okay, and that's going to be the piece over here. So when we call reset, we're going to do that. We're going to get the new piece. And that's going to allow us to get everything. Okay, next, inside of our drop method here, notice we left a comment. It was to get the next piece right here. So we're going to go ahead and do that. And so remember our, well, we got a few things to do here actually. When we drop, this is what's going to tell the game that this is at the bottom. We've gone from wherever it is to hit the bottom. So we want to make sure that we get this piece, or this method, to do the moving of the next piece over into the game, and then we get the next piece after that. So we've got freeze, we've got clear lines. Okay, we've gone through here and seen if we're at the top, and so therefore, we've finished our game. After we've done that, we're going to do this.piece equals this.next. Okay, and this is going to transfer the piece that was here into the piece that is going to be the one that shows up here. But if you remember, the game context for these is backward. No, it's not backward, it's just wrong. So next right now thinks it's over here. We need to move that into the game context as well. Otherwise, it will just try to draw everything over in this canvas rather than this canvas. So all of our logic now has been working with this.piece, so we've successfully moved that over into there. But the next thing is going to say this.piece.context equals this.context. Okay, so again, this.context, this is the UI section that we're playing our game in. So by telling it that it's no longer the one over here, but now it's the one we're playing our game in, this is going to allow our piece to draw itself inside this section. Okay, so those two lines will successfully move the next piece from here into the actual game. So now that we've done that, we need to tell it to reset itself by calling the set starting position. Okay, and that's going to tell it to start up here at 0 on the Y, and then remember, depending on the piece, it's going to be 3 or 4, so it starts more or less centered. Okay, then we're going to tell it to get the new piece. Oops. Because we then want to tell it to put the next thing over here. Okay, so with those two things, we now have the capacity to basically do all of the next, the drawing and everything over here. This is going to do that over here, and then this one over here. So we should have everything we need. Now, when the game updates, because remember, we're dropping our piece one at a time. We don't need to worry about drawing this. Okay, so here in our draw method, we can just leave it like that because the next piece isn't going to move. So once it's drawn, once we've done the draw method here, we don't need to do it ever again until we get a new one. And once we move that other one over here, then the rest of our logic, because we moved, remember this next becomes this dot piece. So because we moved that over here, when we call draw, this dot piece dot draw is going to be whatever was over here, the next one. So that should get us over to where we want to go. Let's see what kind of bugs we introduced. Yep. Cannot read null of this.ctx next. Okay, so right now it looks like ctx next we're not doing everything properly with. Remember, we used null over here. Okay, so now is when we actually need to go in and change that so that we're giving it the actual context of the game board that we want to use over here. So we currently don't have anything that's going to represent that piece. So we have the game canvas and game context for the game area, but we don't yet have anything for the next section. Okay, so here's where we're going to do that. So let's look at our HTML. So remember, our HTML is what defines that entire thing. So we have a canvas here, okay, and that canvas is going to be used for, it's what we're doing all the drawing inside here for, is that canvas. Okay, so we need a new canvas, and if you see, we do have one right there, and that canvas is going to be the one that represents the next section over here. So all we need to do is get a reference to that inside of our game logic. So we come back here to our index.js. Notice to get the first one, we did this get element by ID board. Okay, and if we look at the ID of this canvas, you'll see it's board. So to get the element for our next piece, we can just use that same thing, but this time the ID is going to be next. So let's come over here, and we're going to say const next canvas equals document.get element by ID next. Okay, so now we have access to our next section. Okay, and it's complaining because we're not using it. That's all right. So we're going to say const next context equals next canvas dot get context to be. Okay, so just like we did above, here's our game canvas, game context, next canvas, next context. The code is exactly the same except for we're replacing the game board stuff with the next piece stuff. So now we can replace this with our next context. Okay, let's go ahead and save that. So now when we run this, we should be seeing something over here. It looks like we're seeing something up here, which means we're not setting up our context quite right. Okay, so you can see that it is drawing. There's this tiny little red piece, and if we go to the next thing, we should see, okay, so we did get another red one. And you can see there's a tiny little, looks like it's orange. Yep, oh, looks like it was yellow. Okay, so it is working properly. The problem now is just that we aren't getting the piece to show up very clearly. Okay, we're also not getting collisions on our pieces because we haven't done that yet either. So go ahead and refresh that so our game doesn't keep running. Let's transpile some modules. So we need to set up that game context to have the correct size. Okay, so to do that, we are going to create a new method inside of our index.js file. Okay, so we have our reset game. Just below that, I'm going to create a new method, new function, and I'm going to call it init next. Okay, so here's where we're going to do all the sizing for our next canvas. So we're going to say next canvas, sorry, not next canvas, next context, canvas, width equals 4 times our block size. And remember, we didn't have block size before, so when I hit tab, it automatically pops that in here for me. Okay, then we do the same thing for the height. Context.canvas.height equals 4 times our block size. Okay, and then lastly, we need to set the scale. So next context, scale, block size, block size. Okay, this is going to set up our canvas so that it's the sizing that we want. Remember, we just had the 2 or 3, just a tiny little couple of dots over here, just a couple of pixels. This will scale things up for us a little bit better. Okay, so collapse some of these so you can see where we are again. All right, so we've got our event listener for the click event handler. Okay, up here underneath our board. So we just really need to call this anywhere. So I guess it doesn't actually matter where as long as we have the board created. Not even that really, even just the next context created. So I can just put that right here. Okay, and that is going to set everything up for us. So now if I save, over here and refresh, let it do its thing. Okay, now we get that nice, visible, so not tiny little pixels piece over here. Okay, so now we can move things around. Looks like we're not calling clear anywhere. Okay, so looks like it was just a simple typo. Here inside board.js, we have to get new piece. Notice I have WDITH, and width is spelled WIDTH. Okay, so if we do that, we save it, reload this, does its thing. There we go. We hit play. Okay, so we have a line, have our next piece, which is a line. Go ahead and drop that. Okay, notice now it clears and everything works fine. Okay, but we still have a problem, which is well, I guess I should make it actually a problem. If I try to put this new piece on, notice that you just sort of overlap each other. Okay, if I fill up the whole line, our clear lines logic works because it erases them, but it doesn't really work the way Tetris is supposed to if I can just sit here and stack all of my pieces on top of each other until one of them finally erases it. Okay, so we need to adjust how we're determining if something is in a valid place or not. And that's going to be done in our valid method. Let's come up here. Okay, so right now we're looking to see if this is empty, if it's inside the walls, and if it's above the floor. Okay, so we're going to change that is empty. We're going to modify it to say whether or not there's a piece that already exists there. So let's come down here to our is empty. Okay, so right now we're just looking to see if the value is equal to 0 because zeros represent there's a space. So that's just going to be looking at the piece to see if that piece has a 0 in its grid. That doesn't determine, obviously, whether or not anything else already exists there. So we need to modify this a little bit. So we're going to change this to B. Rather than taking the value, we're going to have it take the x coordinate and the y coordinate. Okay, and now we can return this.grid our y location, and we're just saying there, does the y exist? Okay, so we're actually going to say exclamation point this.grid y. So we're going to say that it does not exist. Actually, you know what? We're going to do this backward. So we're going to do this.grid y. We're going to say and this.grid y x equal 0. Okay, so here we're going to say the grid itself, the row exists, and the spot in that row is 0. If it is, then we're in a good location. So I'm actually going to change this to be, rather than is empty, we're going to rename it something a little bit better. I'm going to say not occupied. Okay, so what we really want to do is test to see that this is not an occupied piece. And so this will do that for us. So now we can come back up here to this dot is empty, and we're going to say this dot not occupied. And rather than passing in the value, we're going to pass in the x and the y. Okay. So this is now going to allow us to check to see, is this spot occupied? And if it is, we don't want to use it. Okay, and that should get us where we need to go as far as that goes. Okay, but lastly, we still want to check to see that the value here is actually a 0, because if it is, then we still need to take care of that. So we're going to say value equal 0, or it's not in an invalid location. So we're going to put these parentheses around here to indicate that's not that's a valid spot for it to be. Okay, and actually, sorry, I need to change some of the logic here. So this dot not occupied, I'm going to change this to be and this dot inside walls and this dot above floor. Okay, so we want all of those to be the case. So not occupied, and it's inside the walls, and it's above the floor. Okay, so either the value is 0 or all these things. So let's go ahead and save that. Just do a refresh to make sure. Go ahead and play. All right, so put this over in the corner. I should be able to stack that. Okay. Now we can see that it is able to detect that that's changed. There we go. So now everything is working the way we expect it to. Okay. So now we can check to see that our logic for handling if the game gets too high works. Okay, there we go. They tried to put this piece in and couldn't, so it just said game over. All right, so we now have something that can detect that there are collisions between our pieces. We have the ability to spawn new pieces. We can show what the next piece is. Little clear lines if they go all the way across. Okay, so the last thing I think we're missing as far as gameplay goes is the ability to rotate the pieces. Okay, well, silly me. This is what happens when you record things on different days. We already did the rotate thing. And you can see we have the rotate method here inside of our shape.js. And we are actually calling it when we do this right here. And if we look inside our constants, you can see that it does call rotate. So I come over here, I can move this, and if I hit the up key, okay, that will actually rotate it. And I can get things to work exactly as I expect. So we should have a fully playable game now. There isn't anything else left for us to do as far as the actual gameplay goes. Okay, if I hit the play button again, that's going to reset us. And we can play a full game of Tetris. Okay, so the last thing you might be looking at is, well, what about these three pieces here? Okay, our score, lines, and our level. Well, Level is going to be the tricky one because that's actually going to make things faster. Score and lines, though, should be fairly straightforward. So we're going to start with those, and we'll add in level later. Okay, so we're going to go back over to our index.js file. We're going to go all the way to the top. And right up here where we're defining all the stuff that we need for our game, this is where we're going to define some pieces to hang on to these values over here. Okay, so I'm going to say const account values. Oops. Values equals, and here we're going to make it an object. Okay, so now remember, in computer science, we use things or terms that people are familiar with, things like object and well, I guess that's the big one. What that means is it's just a way to represent something that we would think of in the real world. So if I want to represent a car, okay, I could make an object that is representing a car. Now, it's obviously not going to be a real car, but this object could have things that a car has, such as a car can have a make. Okay, and let's just do that. And then could have a model. And could have a year. So on. It doesn't actually have to be like a real car, because obviously we can't put a real car into a program. But we can use an object to represent that car so that it has things that it represents or that it expects to have. But inside here, we're going to have the same things we have over on the right-hand side. So we're going to have a score, we're going to have a level, and we're going to have lines. And we're going to put our semicolon at the end. So this now is going to be used to represent the stuff over here to get our game over. So to make this a little bit easier, we're going to add ourselves a little helper function. We're going to call it update account. Okay, and this is going to take a key and a value. All right, so first thing we're going to do is get the piece over here in the UI that represents the thing that we're changing. So if we look at our index.html, you'll notice we have the same names. So we have a score, lines, and level. Okay, so those are the same names we have here, score, lines, level. So that key is going to be one of those three things. So we're going to have the element. We're going to do the same thing we did before, document. I can spell it right, document. Get element by ID. And we're going to use the key to get that element. So that key is going to be either score, level, or lines. So it's going to get one of these things, score, level, lines. Okay, so now we can change the stuff that's over here in the screen. So we're going to say, just make sure we got something, because somebody could give us a key that doesn't exist. Let's just double check that we got what we want. Okay, and we're going to say element text content, text content works, equals value. Okay, so because this is text, we're just going to tell it to update the text of that particular node to whatever our value is, which should be a number that represents one of those three things. Okay, so once we've done that, that will update the account stuff for us. That's going to do all the things on the screen. We're going to do something a little bit tricky here. We want to control how this thing gets updated. Okay, so to do that, and actually I'm going to move it up here. Whoops. Okay. I'm going to create an account object. And we're going to introduce something from JavaScript known as a proxy. So proxy allows us to control what happens with this object. So right now, if I just wanted to say account values.score equals 10, I can do that and nothing can stop. I can also say equals hello world. That also is perfectly valid. But obviously a score can't be hello world. That's not something we want to allow. Okay, so we're going to use this proxy to then allow us to handle that. We're also going to use it to call this update account to actually update these values whenever these things get set. Okay, now there are other ways of doing this, but this is just the way we're going to do it for now, just to kind of keep things all in one location. So we want to change what happens when the value is set. Whenever one of these things gets set, we want to be notified. We want to be able to take care of that. Okay, so we're going to use the set key to tell us that's what we want to do. We're going to use the target, the key, and the value. And this is going to be a function. So the first thing we're going to do is say the target's key equals that value. So that's going to take and say, all right, this key, whatever that may be, score level lines, we're going to set the value equal to that. Okay, that's going to allow us to update that actual value. But before we do that, we can check and say if, let's say target key not equal to undefined. Well, let's just actually do this. If it is equal to undefined, okay, then we want to do something different. So we can actually just return. Oh, yeah, it doesn't like the double equals, it wants 3 of them. So that's going to tell us, okay, if they're trying to set something that doesn't exist up here, don't do it, just move on. Okay, next thing we can check to see is if isNan. Now, isNan stands for is not a number. So if they pass something in here for value that checks to see that isn't something we want to use, we can use this isNan to do that. Now it's tricky. It sounds like you should be able to pass anything in here, and if it's not a number, it would work. Okay, but sometimes things are a little bit tricky that way. So we're just going to use it naively and not worry about the rest of it. But if you're ever doing this in a real application, you may want to look more into how this works. Okay, so if it's not a number, then we don't want to do anything with it either. If both of those checks pass, then we can do stuff. So then we'll set this, then we're going to say update account. So we're going to call our function down here. We're going to give it the key and the value. Okay, we're going to return true. And actually, that reminds me, we can't just return, have to return false. Okay, and that tells us that this didn't actually work. This tells us that it did work. All right, so now we have this thing. So whenever we try to set these values, we'll also set them up here. So we can do it all in one way. Okay, again, like I said, there are a number of different ways we could have done this. This is just kind of the simplest, and it uses something from JavaScript that's a new piece that's kind of nice to know about. So we can just leave it like that. Semicolon. All right, so now that we have the account stuff ready to go, we need to be able to use it a number of different places. So the first place we want to use it is inside of our board here. So I should have actually moved that up above. I didn't think about that. So we'll put this up here. Okay, we move that up. We want our board to be able to update things because it's the thing that's controlling the game. So it knows when things like a line have been erased, when we get game over, all that kind of stuff. So we're going to give it these contexts. We're also going to want to pass in our account. Okay, so now that the board class has that, we should be good to go to get everything set up that way. But before we go to the board, let's come over here to our reset game method. Board.reset is going to do its thing. Notice we're resetting our time to this object. Okay. We're also going to say, well, actually above the time, we're going to say account.score equals 0. Account.lines equals 0. Account.level equals 0. Okay, reset our board. Now down here in time, we're going to have our start and our elapsed. Those are both going to be 0, but our level, we're going to do something different with that. Okay, so we're actually going to say level, and we haven't defined what that is yet. Account.level. And so this level is going to come from our constants piece. It's going to have some things in here defined. But notice we're telling it which one to get by looking at the level that's here. Okay, that's going to become important later because as we progress through the game, we want to be able to change that level and have it say specific stuff when things change. So we're going to use the account level to do that. So let's come over here and we're going to get our different constants. So constants.js. So we're going to do some more of these. We're going to have another one of them. So we're going to say export const level. Okay, this is going to be an object. And here we're going to say which one that we want to use. So 0 is going to be 800. 1 is going to be 720. 2 is going to be 630. And for the sake of easiness, I'm just going to skip ahead here. So 3 is the last one. Let's put those in. Okay, so what these are their timings for our game. So you can see as we're on level 0, okay, that's going to be 800 milliseconds to make things move. As we get to level 1, it's going to be less, 2, less, until we get all the way up to 20. Okay, in this case, then it's really, really fast. So we can put a semicolon. We're going to do our object.freeze level. Okay. Yep. We can save that. Reload our game. Come back over here to our index, and this doesn't exist anywhere. So let's come back up here to our constants, and we're going to say we also want to import level. There we go. All right. Come back to our constants, and let's just go ahead and define all of these things while I'm thinking about it. So we've got our level. Let's do the next one, which is going to be points. So const points. Let's export const points equals, and again, it's going to be an object. So we're going to say single is worth 100 points. Double is worth 300 points. Triple is worth 500 points. Okay, Tetris is worth 800. And then if they get a piece down, so it hits the bottom or it hits the top of another piece, we're going to call that a soft drop. We're going to say it's worth 1 point. Okay, and we're going to say a hard drop, which is when they actually hit the space key to drop things all the way to the bottom, is worth 2 points. Okay, so we got our points defined. That's going to help us later on when we're doing our game stuff. So let's go ahead and save that again. We can come over here to our board. The first thing we want to do is change our constructor to accept the account information. Okay, so we can say this dot count equals account. Okay, let's come over here. Let's just add these in. These don't actually do much, they're just sort of descriptors, but I can say account, and I can say, what was it when we did next piece? So I forget if that's how we actually called it. Down here, next, not next piece, just next. Okay. These are just going to tell anybody that looks at our code what stuff we have that's available to be used. So go ahead and just put those up there. All right, so now that we've got that, we can start getting some of the pieces in place to do some scoring. Save. All right, so inside of our board, the place where we need to look for our scoring is going to be in the clear lines method. So previously we had done this calculate score piece right here. So now we just need to fill that in. Okay, so if lines greater than 0, which means we have actually gotten rid of something, then we want to calculate a score for the person. So to do that, we're going to say this.account score plus equals this.get lines cleared points. Okay, so we haven't written this method yet. We're going to go ahead and do that now.
that this method is going to calculate the number of points we get for clearing lines. It's going to use that lines variable, or I guess constant, that we created over in our constants file. So let's just come down here, and we're going to say get lines cleared points, and that's going to take the number of lines that got cleared. Okay, so to do that now, we're going to say const line clear points equals, and now we're going to do some checks. So we're going to say, we're going to use a new way of checking to see something. So before we're using these if statements, we're going to say if this is true, then do the stuff here in the middle. If lines is greater than 0, then do this stuff in here. Okay, we're going to do the same thing, but we're not going to use the if keyword to do it. So we're going to use something known as a ternary operator to do it. Okay, so it's going to look a little weird, but it's doing exactly the same thing. So we're going to say if lines equal to 1, okay, we only cleared one line, then we want to return, we want to set points, okay, and we haven't brought in points yet, so note right here, auto import from constants. If I hit tab, it does that. Okay, dot single. That's 1 point for one line. Okay. Otherwise, whoops, if lines is equal to 2, then points dot double. Okay. Otherwise, if lines equal to 3, then points dot triple. Otherwise, lines equal to 4, then points dot Tetris. Okay. And if it's none of those, then 0. Okay. So if lines is 0, or if somehow they said that they cleared 5 lines, which isn't possible in Tetris, okay, 0 points. So now we can return, oh, there we go. There we are. This.account.level plus 1 times line clear points. And so what this is going to do is we get more points for being on higher levels. So if level is 0, because remember we start on level 0, which is actually level 1, then 0 plus 1 is 1, and line clear points is only worth 1 times that, so it's worth whatever this value is. Then if we go on the next level, so 1 technically, 1 plus 2 will be 2, line clear points will be double. Okay, next is going to be triple, 4 times, 5 times, 6 times, 7 times, 8 times. Okay, so points are going to be worth a lot more the higher up you go. So that's going to be used up here. So now we've set our score. Okay, so the next thing we want to do is deal with our lines. Let's equals lines. So that'll update that value there. Okay, then we want to say if account dot, whoops, account dot line is greater than or equal to, okay, and here we're going to say lines per level. Okay, we haven't defined that constant yet. I skipped it, completely forgot about it. Over here to our constants. Okay, so we can see, we can define how many lines per level we want this to actually be. So let's come up here. We're going to say export const lines per level equals, and I'm going to just set it at 10. If you want to make the game easier, you can set that to a smaller number. If you want to make the game harder, go ahead and make that to a higher number. Okay, lines per level, 10. So now that I've got that, so it's not defined, so we got to come up here to our constants. Lines per level, there we go. Back down here. Okay, so if the number of lines is greater than or equal to the lines per level, that means we've completed this level. So we can actually go back, or update our level to be the next level. All right, so over here, we want to do this .account.level plus plus. Okay, now this plus plus thing is going to pick whatever this is, add 1 to it, and then save it. So it's the same thing as saying this .account.level plus equals 1. okay, which is the same thing as saying this.account.lines equals this.account.lines plus 1. Okay, so this is just going to add 1 to our level. Then I can say this.account.lines minus equals lines per level. Okay, we're going to do this and say, all right, let's say they got 12 lines because they got, let's say, a Tetris at the end, so put them up to 12. When this comes in, we're going to say, well, 12 is greater than lines per level, so we're going to increment our level, but then we want to reset them back to a 0 so that they know how many lines they have left to go before they get to the next level. So if I subtract this, that's going to give us 2, which means they're on lines 2, so they have 8 more to go before the next level. If we wanted to, we could add a total lines piece over here. We'd need to add that to our account object, and we could say this.account.total lines just plus equals lines. Okay, that way we could show them how many lines they've gotten rid of entirely. But it's not hard to figure out. You can take level and just say, take your level, times it by lines per level, so 10, and then add the lines here. So if they're on line level 2, 2 times 10 is 20, plus the lines here, let's say it's 2, that's 22. Okay, so you can figure it out. So now that we've got that, we now need to increase the speed of our game. So to do that, we're going to come over here, and we have this time object. All right, so we have our time object right here. That is going to need to be changed. So we actually need to move this right here. We're going to set this right here equal to that. Okay, and then we're actually going to take this and bring it up here. Now we can take that and we can pass it into our game board. Okay, so now down here we need to reset things just like we did for our account. So we're going to say .start equals 0, time.elapsed equals 0, and time.level equals level count.level. And reset everything back to this right here. And then as we're using that time object down here, it'll just get updated like normal. Okay, so we need to change that. Before it was just kind of there because we didn't need it in the game, but now we do, so we're going to update it. So now we can come over here into our board. Let's come back up to the top. We're going to add in time. Okay, we're going to come over here and say time, and this.time equals time. All right, so now that we have that, when we come down here to our clear lines section, okay, we now have been updating our level, which means we now need to tell the game that we need to update the speed that it's running at. So we can say this.time level equals level. Okay, and again, we can auto import that from our constants. Count.level. Okay, so when we level up, then we're going to increase our speed. Okay, so we come over here. Notice right here we have our elapsed and our start. It's going to keep track of how much time is going on. Okay, start equals now. Okay, so we need to tell it that we want to use the level now to handle how things are gonna change. So if we come back into here, this is where we're going to use that determination. So we look at our constants. Okay, so level 0, which is our first level, is 800. Right now, we have that set to 1000. Okay, so instead of that, we're just going to go ahead and update it to use our time dot level. Okay, so by using that variable, now whenever that gets updated, that will be used to determine how fast things get set. Okay, so let's go ahead and save everything. refresh that. Transpile some modules. Okay, so we should be able to play. See if I can erase one of the lines. And we still need to do one more change to get it to do the soft drop and hard drop. Now we're just checking if the lines work. Okay, there we go. So we got rid of one. We can see we got 100 points. Lines 1. Okay, so we can do that. Oh boy. Here we go. Oh, I did it the wrong one. Well, that's all right. We can get the blue line. Okay, there's our 2. All right, so let's go back over here. So when we do our key codes down here, these are going to be used to determine, what happens in our game. So if it's the space key, then we use this to go ahead and drop it. Okay. Otherwise, we just do our thing. So here's where we're going to check to see if we should be giving them points for doing a hard drop or a soft drop. Okay. So we can see right here. So this is the space key, which means that they have done a hard drop. Okay, so we want to give them points for that when we're finished doing the drop. So after our while loop, we're just going to come in here and say account. Oh, actually, no, we want to be inside the while loop. Okay, because actually we want to give them points for every level of height. So if they're here, they get 2 points. If they're here, 4, 6, 8. So they get more points if they drop it from higher. Okay, we're going to say account score. Okay, we're going to say plus equals points. Bring that into our constants file. Dot hard drop. Okay, so every time, so if they drop it from up here, then all of these lines, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If they drop it from there all the way down, that's going to be 18 times our hard drop points, which is 2. That's going to be 36 points for them. Okay, but if they only drop it down here, that's only going to be 4. So more points for dropping it from higher points. All right, so down here when we do our p-stop move, okay, here we want to check to see if event.keycode is equal to key.down. Okay, and that means they code to go down manually. So we're just going to say account.score is equal to points.soft. Again, if they're up here and they hit the down key a bunch of times, and that's going to allow them to do that. The way we have it set up right now, that can be a little bit cheesed to gain a couple extra points, but they won't get many, so we're just going to go ahead and leave it. All right, so let's save that. I'm going to go ahead and tell it to refresh. Let it do its thing. Okay, so let's hit the play button. Okay, I'm hitting the down key. I'm getting some extra points. I bring this over here and hit the space key. I missed. Well, that's the danger. Okay, I get some extra points because I'm hitting the down. See if I can slip this in, get some little things here. Make sure I'm not off this time. Okay, there's a hard drop. I want a hard drop. Okay, keep that there, hard drop. So you can see those are now working. Hard drop. Okay, there's that. And I know this isn't how you want to typically play the game, but I'm just going to see if I can get rid of some lines as possible, as quickly as possible. There's 2. Make sure that our level code works properly. Okay, so there's another one. That. So we're on 5. Uh-oh. Oh, that was probably a mistake. Need 4 more lines. There's 2. Oh, now I'm starting to get in trouble. It's probably going to be a mistake later. All right. Again, I'm not worried about winning. I just want to get some lines. So I'm going to just go ahead and do that. Go ahead and fill that in. I'm starting to get in trouble again. I should have been playing the way you're actually supposed to play. That way I could actually, get something. All right, there's one more. That. There, come on, give me something I can use to get rid of these lines. It's not going to do it. Oh, yes, it is. That's the one I want. Excellent. Okay, so probably one of the worst games I've ever played, but you can see we did get level 1 and our lines did reset. Okay, so that logic is working, which means we now have a completely playable full game of Tetris. So feel free to add whatever changes you want. If you want to come in here and make the pieces different colors, okay, you can do that just with the colors piece here. So you've got cyan, blue, orange, yellow, green, purple, red. You can actually change these to be almost whatever color you want. So go ahead and do that. If you want to change the shapes, you can do that as well. These are the official Tetris shapes. Leave our moves. I guess you can redo our keys as well. So if you want to change these from the arrow keys to be the WASD keys, you can do that. Just look up the key codes, and then you can use whatever you want there. So make changes, make these so that they're faster and harder. Change point values if you want. You can make it your own. You can even change, what it says up here and how things are displayed over here. If you want to add in that total lines piece that I talked about earlier, you can do that. Fairly easy to do. But yeah, make it your own and enjoy. If you want to start from where we are now, hopefully you've been wanting to build this along and you've been able to do that. But if you just want to kind of start from the beginning, you can come to this website here. So it's codesandbox.io /s/kcc-2020-js, and then this is JLSUE. If you come in here, this will take you where you want to go. You can hit this fork button. Okay, so I can fork it as my own account. If you don't have an account, just hit the button and it'll just fork it for you, but of course you won't be able to save it. So make sure you do that. And then you can start making changes however you want. Obviously you can't change mine, so as soon as you try to change something, it'll fork it for you. But yeah, that's Tetris. Enjoy.